All right, so this is our second video of our test review. We're on the second page of 4 for our review. Question number 2 here says find the distance between these points. You've got 1, 3 and 5, 8. We'll simplify any radicals that we have. So for our first test, you need to know the distance formula. D, our distance, is equal to the square root of quite a bit. It is x2 minus x1 squared plus y2 minus y1 squared, where in 1, 3, I've got x1 and y1, and 5, 8, I've got my second x and my second y, so I've got x2 and y2. And now I'll just plug in these values and simplify what I've got. So when I say x2 minus x1 squared, that's 5 minus 1 squared plus 8 minus 3 squared for y2 minus y1. If I continue on underneath my radical, doing a couple steps at once, 5 minus 1 is 4, and 4 squared gives me 16. 8 minus 3 is 5, and 5 squared gives me 25. So underneath my radical, I've got the square root of 41. Now, 41 is not a perfect square, so I can't just say, well, that's equal to 8 or 4 or 6 or anything like that. As well, 41 is prime. No other number will go into 41 except 1 and 41, so that means a perfect square like 4 or 9 or 16 or 25 will not go in there, so I would just leave this as square root of 41. I do not have to simplify any radicals here. However, you may have to simplify a radical or two on your test, so make sure you look back through our notes on distance formula where we did simplify some of those. Moving to number 3, give the equation of a circle with a diameter that has endpoints of -3, 1 and -6, -7. So in addition to the distance formula, you need to know the equation of a circle, which we said was x minus h squared plus y minus k squared is equal to the radius squared. Definitely have that in your memory for test 1. So in this formula, I want to fill in for h and k, which that gives me the center of the circle, and I want to fill in for r, which is the radius of the circle, which we'll get this from the diameter information here. So it helps to do just a quick sketch of what's going on here. So here are my axes. At the point -3, 1 would be over -3 up 1, so maybe somewhere about here. And then -6, -7 would be somewhere down here. So now these are endpoints of a diameter, which stretches all the way across the circle. So that means you've got your circle with a half up here, a semicircle up here, and a semicircle down here. So something like this. So I need to first off find, well, what's the center? What's the h, k here? The center is found by using the midpoint formula. So if I can find what's right in the middle of these two endpoints of the diameter, then I can find the center. So to find the midpoint, you add your x's and divide by 2. So if you think about this as x1 and y1 and x2 and y2, what you'll do is you'll take -3 plus -6, divide that by 2. That'll give you the x coordinate of the midpoint, and then take 1 plus -7, divide that by 2. That'll give you the y coordinate of the midpoint. So I've got a -3 and -6 from here from my x's. I've got 1 and -7 here from my y's. And so if I combine these together, I'm going to get a -9/2. And I'm going to get a -6/2. Now, the -9/2 does not simplify, so that is my h. -6/2 is the same thing as -3, so that's my k. And now be careful when you plug these in. So my left side of my equation is going to be x plus 9/2 squared. and then plus in my parentheses y plus 3 squared, 3 in place of that k. So remember, when you pull it out of parentheses, you really do the opposite. So here where it's y plus 3, I'm going to pull that out as a negative 3, which I got over here, and I'm going to pull this out as, instead of a positive 9 over 2, when I use it, the center would be at a negative 9 over 2. And now for my radius, I can use the distance formula to find, well, what is the diameter? What is the distance across the circle from the given point negative 3, 1 to the other given point negative 6, comma negative 7. And then I'll divide it in half to make it into the radius. So to do that in green, again, I'll just use the distance formula from up above. The distance, or my diameter in this case, it's the square root of x2 minus x1. So I'm looking at negative 6 minus negative 3 squared, plus, and then y2 minus y1, that's negative 7 for y2, minus 1 for y1. So if I continue simplifying this, negative 6 minus negative 3, that changes to a plus. So negative 6 plus 3, that's negative 3 squared. Negative 7 minus 1, that's negative 8 squared. And when I square these, when we're scoring a negative, will lead you to a positive. So I'm going to get a positive 9. Negative 3 times negative 3 is a positive 9, plus 64. Negative 8 times negative 8 turns to that positive 64. And so I get the square root of 73. And once again, that doesn't simplify just like the square root of 41. 73 is a prime number. Now that's the distance all the way across the circle. This is the diameter. The radius is just the diameter cut in half. So the radius in this case is the square root of 73 divided by 2. And so now when I go to square this, because this is equal to not just the radius, but the radius squared, if you square the top, well, the square root of 73 squared, the squared and square root, as we talked about, are inverses. They cancel out, so it's just 73 on the top all over, and on the bottom, if you square the 2, you get 4. Again, I'm just saying r squared is going to be the square root of 73 over 2 all squared. So the squared and square root cancel out to give you just 73, and 2 squared is 4. Probably one of the more complex problems on the test. Moving to number 4, does the graph represent a valid function, either yes or no? Number 4 here is a no. I'm using the vertical line test. If I draw a vertical line through 4 right here, I'm crossing 2 points at once. We're looking at negative 4, comma 4, and negative 5, comma 4. Times x minus the same y value. This is not a function. Whereas this linear graph over here, yes, this is a function. No matter where you draw a vertical line, it will only cross the graph one time, here or here. So each vertical line only crosses once, where this vertical line crosses the dots twice. So that was a no. Number 5, a little bit of function composition going on. So I've got the function f of x is equal to x squared minus 2x plus 3. I want to evaluate f at 4x plus 5. So essentially, wherever there is an x, I'm going to plug in 4x plus 5. So plug the 4x plus 5 in here, and the 4x plus 5 in here. So I'm looking at 4x plus 5 squared minus 2 times 4x plus 5 plus 3. Now be careful with this 4x plus 5 squared. It's not just 4x squared and just 5 squared, but it is 4x plus 5 times 4x plus 5. And I'm almost out of time on this video, so I'll wrap this up starting in video 3.